2, we would have called this basically function operations. We want to add functions together, subtract functions, multiply functions, divide functions. So that's what we mean by combinations of functions. This slide is mainly intended to introduce a new notation. It looks different than the way we represented the function operations in Algebra 2. So the big difference is in the pre-calculus textbook, it's going to add f and g and then say of x, which really just means f of x plus g of x. That's the way we saw it represented in our Algebra 2 textbook. I'm not sure what it looked like in Algebra 3. So you could probably fill in the others. F minus g is f of x minus g of x. F of x times g of x. F of x divided by g of x. I picked up that red one and it's really crazy. On this slide, I'm also going to just write a couple of helpful hints, reminders to be thinking about in terms of the big scope of things, the big scope of all mathematics, not just this tiny viewing window of honors pre-calculus. In mathematics, anytime your goal is to add or subtract something, I'm going to be a little bit patriotic with the red marker on the fritz. You are basically working to combine like terms. Isn't that nice? If only I could get all of them to do that. I'm going to have a rainbow effect. The red marker's on the fritz. I can't get it to stop thinking, so I gave up.
So put going down for the third one, that is going to be right.
I don't like it. Oh, she likes it. She likes the changing colors. It's so exciting. This is true for honors pre-calculus and beyond to things that you did from kindergarten long ago. Like anytime you add and subtract something, they have to be like terms in order to be able to put them together. Okay, so always add and subtract. Think about combining like terms. In multiplication, we're basically working to distribute. If you're working with polynomials specifically, binomials specifically, you might call that the process of FOIL. Okay. FOIL is just distributing. So multiplication is distributing. It is what it is. Division is generally pretty easy. Sometimes there's nothing you can do other than to put f of x over g of x. That happened to us a lot last year in Algebra 2. Since we've studied rational functions already, we do know that there's one thing we can try. We can factor if possible. Are you guys all smiling when it changes? I hope you are. Okay, you can factor if possible. And if it factors, then you can cancel common factors if they exist. Now, this is not always the case. And sometimes you won't be able to factor. I try that Sammy really is smiling. And there's one other thing really important, particularly with this function. G of x cannot equal 0. So always remember that your denominator in a fraction, not possible to be equal to 0, then you have something that's undefined. We're going to be listing out domains in our examples, so we need to be thinking about that specifically in division. Okay, there can be restrictions in the other ones, but most often you'll have to pay careful attention in division to the denominator. So the next slide is examples with two linear functions. These are very basic examples. Reason being, this is kind of a basic idea that you've seen multiple times. You've seen it in Algebra 1, you've seen it in Algebra 2. So we just want to make sure we're all okay with what the idea says here. If f of x is equal to 5x plus 2 and g of x is equal to 3x minus 4, can we do basic function operations or combinations of functions and identify domain and range? The answer is yes. So f plus g of x, we're going to add the two functions. Some of you could probably do this with little to no work. I'm going to show what I'm doing when I add the two functions. 5x plus 2 plus 3x minus 4. I think about adding and subtracting in math, that is combining like terms, so I'm going to get what? 8x minus 2. Thank you, Jennifer. 8x minus 2. That's my new function, a result of a combination of two functions. I don't have to do any solving. It is not an equation, so I leave it alone. We should chat really quickly about the domain. What's the domain of 8x minus 2? Anything you can't put into 8x minus 2? So the domain is all real numbers, negative infinity to positive infinity. I can multiply any number I want by 8, and I can subtract 2 from that, and then I'll have no difficulties. Okay. What would you tell someone who's starting out in function operation is very important if you're going to do subtraction? Always remember to distribute the negative to the second function. So if you have multiple terms, you've got to subtract all the terms. That's like one of those moments, if you miss that on a quiz or a test, it's going to be palm to forehead, stupid mistake. Why did I miss that? I knew that. To help myself out, I often go ahead and show all my work. And when I say I want to subtract g of x, I want to subtract all of g of x. To say all of something in math, use a set of parentheses. Okay. And then we'll remember to distribute the negative to the 3x and to the negative 4, which really results in us adding the opposite of both terms. So I come up on this one with something like 2x plus 6. Domain for 2x plus 6, all real numbers. Multiplication, not going to spend a lot of time on this one. I usually don't have a lot of people have trouble with multiplication. The biggest issue with multiplication that I see is people doing multiplication for addition and subtraction. So instead of combining like terms, they do too much work. Here we would multiply 5x times 3x to get 15x squared. My outside term is going to be negative 20x. My inside term is going to be positive 6x. Combine those like terms to get minus 14x. And then positive 2 times negative 4 is negative 8. So by multiplying those, I come up with something that's quadratic. What should be the domain for that quadratic? All real numbers. Okay. It doesn't get very exciting in terms of domain for these unless you have something that already has a restricted domain, like a radical function and square root function. You can't take square roots of negatives, so that's going to come into play. But normally there's not a whole lot of excitement there. Okay. And the last one is the division problem. So I just divide 5x plus 2 by 3x minus 4. I would check to see if those factor. If it was a trinomial, I could factor into two binomials. Here I'm just looking for a greatest common factor, but nothing happens. Don't get cancel happy and try to make 2 over 4 1/2. Those are terms, not factors. So we leave it as is. Did you see that?
Yeah, that's weird.
Is there a bug in here?
Yeah, there's a flaw.
A fly. A fly. Is that all? If there was a moth, I didn't want to be in here anymore. kind of scared of those. I don't know, they just freak me out.
There's one.
I saw a white one on display the other day when I was cleaning. It looked like it had been painted white, like completely white. I've never seen a white moth like that before.
Oh, I know one.
Yeah, that's what it looked like. It's crazy. What's going to be the problem with our domain here? We can't have 4/3, right? We're focused on the denominator, which is 3x minus 4. The denominator cannot equal 0, so you could set your denominator equal to 0, figure out what that value is. It ends up being 4/3. To write this with interval notation, we would do negative infinity all the way to 4/3, but we don't want to include 4/3, so parentheses, union, pick right up at 4/3 to infinity, so that 4/3 is the only thing excluded from the domain. So that's a little bit fun. Any questions there? Okay, the other combination of functions besides adding, subtracting, multiplying, and dividing, does anybody remember what the fifth one is? Talked about it already. F of g of x. What are those things called? Super boring? Or super gluing? I was going to say me. Composition. So a composition is not like an operation. It is not adding, subtracting, multiplying, or dividing. Compositions are substitution. So these look like, on the right side, f of g of x is how you saw it in Algebra 2. Of course, we have a new alternate notation, which is this open circle in between, so that when you look at it, sometimes it's like the word fog. It's not fog. It's f of g of x. It means the same thing. And a composition is basically when you substitute one function in for x and the other function. Okay, so we looked at that on that warm-up on Monday, when we did f of x. Okay. The key piece to this is going to be the domain. You need to think about the domain, and the domain in a composition has really like 3 parts to consider. Okay. The first thing you should always consider is what's the domain of the function you're plugging into the other function. So I call it the inside function. What's the domain of that function? That could limit what the domain of your new function will be. Okay, because if you're plugging that in, you're limited to those values of the inside function. Okay. You also need to consider what values of that g of x overlap with the values of the f of x, the outside function, the one you're plugging into. So they work simultaneously with each other. If g of x has a restriction and f of x is all real numbers, when you plug g of x into f of x, you're still restricted by that g of x function because you want to plug into that first. Okay? And then vice versa. If g of x is unlimited, but f of x has some restrictions, when you plug that in, you'll be restricted by the f of x. The final thing to think about is what's in the domain of the composition. You'll choose the set of all x's in the domain of G such that G of x is in the domain of F. And then you also check with your f of G of x function. So you've looked at them individually, and you've looked at them, like what's their overlap. Now you need to see what parts of that overlap agree with the new function created by the composition. Sometimes they're super easy, and then sometimes you really got to pay attention to domain and range. So I try to check 3 domains when I do these problems. The domain of g of x, the domain of f of x, and the domain of an answer, and see where the overlap is. I'm going to skip my easy example. Is that okay? We'll do the harder example. It'll be more challenging. I'm going to skip the easy example. Note that if I ever go too fast, which sometimes I do, we have about 4 minutes left, the notes are always posted online. So if you go to the math part of Quick Vista South, if you click on my name, and you go to my website, and the recent documents, the daily notes are always there. I also always post a video, so you can watch the video notes too if you need to. I'll show you that probably maybe on Friday. I'll have time before we do our aerobics. We're going to let f of x be x squared minus 9 and g of x be the square root of 9 minus x squared. And we would like to find the composition of f of g of x. Okay. And then after we do that, we would like to identify its domain. So thinking about compositions, f of g of x, we want to plug g in for x in f. Okay. So f of g of x is equal to, instead of saying x squared, I'm going to replace x with 9 minus x squared and square it. So that is getting substituted for my x and being squared, and then I still have to write minus 9. Simplify your composition if possible. What happens when you square a square root? Cancels each other out, so we have 9 minus x squared minus 9. And then 9 minus 9 will cancel, so we're left with negative x squared. So my composition function is negative x squared, which if you thought just about negative x squared and labeled the domain there, you would say it would be, Lily? All real numbers. There is no limit to what we could do negative x squared of. Okay. But we have to go back to f of x and g of x as well. What's the domain of f of x? All real numbers, negative infinity to infinity, so no restrictions there. What's the domain of the square root of 9 minus x squared? Positive 3 works, right? Because then it would be 9 minus 9, which is 0, we can do. Negative 3 works, and then everything in between, right? So we would say this domain is negative 3 to 3, which means if I'm first doing this and then plugging it into this, this is now limited by the negative 3 to 3. And then that carries over here. The only things I can put into my composition are negative 3 to 3. Because the composition still has g of x. Okay, so the idea is we're plugging into this one first, then plugging into f of x and getting this resulting value, but we're only allowed to do negative 3 to 3.
So if there's limited, that's going to be domain terms that all limit.
Yes. You should also, sometimes these things will be limited, and then by combining them, it's limited even more. So you might have to look at that final one again, just to make sure it doesn't have extra limits. Okay. Your homework assignment for tomorrow is on your gold sheet. Please note that 31 is listed twice, typo, so I just crossed off the first 31 and left the other one bolded and underlined. That's the required problem. Your problem set's due tomorrow. Stop in and see me if you have any questions. Quiz corrections are due on Friday. Stop in and see me if you have any questions. Function aerobics are this Friday. You should dress appropriately. And your chapter 1 test is next Tuesday. Have a great day, guys.